Welcome to the level 2's NCEA level 2 Algebra speedrun. I did a calculus speedrun before, so go check that out if you have not. For the speedrun to be complete, I must complete every single question over 100%. I believe that is the rules, and I will be using my graphics calculator FX98600G3. Let's get right into it. Okay. 2x minus 3 is equal to 3x plus 4. 2x minus 3 is equal to 3x. It's 12. It's a 3 here. The 15 is equal to x. Was level 2 this it? Were these seriously were may achieved questions at level 2? I do not remember this. I thought they weren't this. Do I need to? It's level 2, so I probably have to factorize the hard way. Square minus x minus 72. Squared minus 9x minus 12. X minus 3. It's x, right, plus. Right. Oh no, that's 2. And then x squared minus 6. 3x squared. So 3x plus x minus 9. Cancels. Just equal to 2x minus 3 over x minus 9. I don't mean. Oh, this is what Yvonne was talking about. Oh. Then it can be presented in the following way. We don't. I see. This is a bit bizarre. George draws a 4x4 square on the calendar to claim that she had. The sums of the diagonally opposite corners are always the same no matter where you make your square. In other words, when you add the numbers in the orange corners, it is the same as when you add the numbers in the blue corner. John as if the claim will be true no matter where she starts the squares. So use attribute to prove that no matter. This is is it restricted to 4x4 squares? I thought, right, because wait, 39 plus 22 is 61, and 18 plus 43 is 61. Wait, why is it restricted to squares? '43 plus 18 is 61. 39 plus 22 is 61. Let's just try like 18 plus 65 is 83, and 60 plus 23 is 83. Why is it restricted to squares? So plus 7x, because this row, each row is like 7, so it's 7x. Then, and the first is 3. So the date will be decided by 3 plus 7x. But I don't know about the Monday, the first, right, in any. Right, okay. Any. So the starting point will be actually, let's say 4 by 4, so 1, 2, 3. So 3 times, for it to go down by 3, it has to be, so there'll be a point here. So a, then this point will be 3 after, so 3 times 7, which is equal to a plus 21. So this could be a, this could be a plus 21. Then this is a plus, so we're going sideways by 3, so a plus 3. So okay, this just named a, b, c, d. So a equals, yeah, there's a. B is equal to a plus 1, 2, 3, 3. C is equal to a plus 21. D is equal to a plus 21 plus 3, which is a plus 24. So we want to prove that. So we want to prove that a plus d is equal to b plus c. So a plus 24 is equal to a plus 21 plus 23, which are 2a plus 24 is equal to. Alright, that's just 1 plus 20. I think that's just there. It seems products easier to prove that. Okay, the left hand side is equal to a times d. Right hand side is equal to b times c. So a times so d, a times 24 is equal to left hand side. Right hand side is equal to, what was it? A plus 3, a plus 21. So left a squared plus 24a. Right hand side is equal to squared plus 24a plus 63. Therefore unequal. Just to prove that it is not. Yeah, okay, it is not possible. So if we try to equate the terms, a squared plus 24, 63 is equal to a squared for a, which gives 63 equal to 0, which is a contradiction, therefore impossible. Will it always be true that the sum of the orange, this must be the same as sum of the blue corners regardless of this? size or shape of the angle. Use algebra. This is such a weird question. Use algebra. So im is, so let's just create, so this be im, this way will be in, so yeah, this is a, so so the top lit top left equals to a, then okay, let's just create a square and create a b c d, then okay, yeah, actually it doesn't matter, a, it doesn't really matter where a starts, then it's just a equals a, b in terms of a is equal to, so b is equal to a plus k, where k is constant, which can be negative or positive. Constant, and -6 is this thing k. That's like the restriction. C is im, one im, yeah, im is just 7m times a, 7ma, which is equal to force. I mean, yeah, of course, most times acceleration is equal to force. B is, and D is equal to times m times a plus k, a plus D equals left hand side, B plus C equals right side, and side is equal to D, A, D is equal to 7ma plus k, C is equal to a plus k, 7ma, left hand side is equal to side is equal. Therefore, claim it's always true. This is such a weird question. This is so weird. Do I need to do I have said the restriction? A plus k, oh, it has to be, must be greater than 0. And a plus a, and a union k is an element of real. Right, was that real? I forgot. Was that? This is such a weird question. No. 1/3 gets x plus 7 to 1 minus I'm overthinking it. It's too hard. No, it could just be any integer, so we could have 1 over 3 plus 2 over 7, which is equal to is it 3 over 20? Is it 3 over 21? No, that's negative. And that's negative 1 over 21, so x squared 21x take away 2 over 21. I think any pattern of this is allowed. And you 2 over 21. Right. Let me put that into over 20. Okay, that is discriminant is equal to b squared minus 4ac. 12 squared take away 4 times 2 times 44 take away 28 56, which is equal to 88. I think that's just it. 2x squared is 12x plus k is equal to 0. Discriminant b squared minus c is equal to 0. Negative 12 squared take away 4 times 2. So k is equal to 0. Minus 8k is equal to 0. K is equal to 6, 18. Then k is equal to 18. Have in the one distinct real root. Let me just do negative 12. Yeah, that distinct. Or just a double it is probably better. 9x squared 2x plus 3 is equal to 0. 9x squared minus 2x plus 27. 9x squared. Right, 27, 27, 9 and 3. Wait, one quick. 9 and 3. 4, 5, 6, 7, 8, 1. Wait, no, what am I doing? What's happening? Okay, 2. And this is a minus firstly. Okay, I did go wrong. What have I said? 4, 5, 6, 7, 8. Is this solvable by hand? Okay, no, I'm just gonna use a quadratic formula. I'm gonna guess. Right. Oh, is this connected with the, no, it is not. So that cross these two out. Negative 2 and negative 3 b squared. 4 take away 4 times 2 4 b squared take away 4 times 4ac just equal to 2 plus minus square root of 4 12. 8 all over 18 should 2 plus minus square root of is it, can that be is this 4 plus 4 times 9 times alright, I think this can be simplified. 18 to square root of okay. Suppose qx if x squared. Yeah, if and g and h the reciprocal plane of qx. Oh, this is weird. So if it's a reciprocal, it has to be 1 over h gx plus f. No, that's what it's suggesting, right? Reciprocal plane of... Oh, no. Oh, no, it's just... h is equal to h squared plus g x plus f. Yeah, and then that's all we want. Oh, okay, this is take away h x squared plus g x take away g x plus h take away f is equal to 0. Okay, so we can cross these two out. If take away h or x squared plus h take away f. Actually, you can just x squared is equal to f take away h. Squared is equal to 1 since we can just cross these. Because each x equals plus minus 1. Oh, it's actually not that bad. Alright, let me just try it out. I want to test some. Just get random numbers like 369. So this equation is suggesting 9x squared plus 9, so it cancels out. Plus 6 is equal to 6. Oh, okay, I see. Okay, that was interesting. Suppose x squared equals 0 has to be x multiple. Q was if gh, right? Q is if gh plus h is equal to if x minus a x gx squared. Oh no, h x squared plus gx if x is equal to x minus ka x minus kb. Right, this okay, we have one more question to go. Hx squared. Can we just cancel squared plus g over hx plus over h is equal to x minus ka. Will the first equation help? X squared plus gx h. Is the first equation helpful? Actually, it might. Must be x. Yeah, okay. I understand why people are saying this is kind of hard. The algebra was really hard. Square plus g is h, which actually we want to I guess negative and change this to negative. G is equal to negative a take away b, and h is equal to ab. So let's expand this. X minus ka over x minus kb. So you got x squared plus this ka is kb x k squared a b. So yeah, if over h is equal to k a b, over h is equal to squared h, k squared is equal to f over h squared. K squared is equal to square, oh no, k is equal to plus minus square root of h squared, I believe. Over h is equal to ka take away kb. Alright. G over h is equal to negative k brackets a. Okay, a plus b is equal. Wait, no, negative. And then no, we want to keep this negative. So k, I bet it's probably nicer. K brackets negative a take away b. So g over h is equal to kg. 1 over h is equal to k. We've got contradicting statements. K squared is equal to f over h. Wait, did I go wrong somewhere? If AB K squared is equal to AB. G over h is equal to negative ka take away kb. K brackets negative k negative b ab. K g. K is equal to oh no, I got plus squared. Can I replace if with something? Don't have if in terms of something. Actually, if we can replace for one, wait, can we replace if it's one in this case? Because if there is one, we can just confirm that. If the age is equal to if over h squared. I can't be bothered. I mean, I would just say k h is equal to whenever h equals k. 7y to the power of 18. Natural log of 2 is equal to natural. 2 log 2 2000. This is a do I need to express it as a rational number? Can I just express it? Oh no, I like being pretentious. Log 3a is equal to log plus log of over 6 all squared log plus log 36 log 3a plus it's a single logarithmic. Okay. Log of 3a cubed over 36, which is equal to log of NCEA constant. Show that x is made the subject. Show that. I don't remember using the part. Like, this is a true statement. Right. Yeah. It's equal to. This is a true statement, but I don't remember using. I'm not sure if this is actually taught, so I'm not sure if I'm allowed to use this. I'll be like breaking the rules, so yeah, let's just go with it. I can't think of any other way. Do we let log 2x minus, no, that's conjugate, so I can't see any other ways to do this. Maybe am I just too unintelligent? I don't know. 2 log 2x minus a log 2c x plus a x minus a 2 to the c x plus ca 2 to the c x minus x is equal to negative a ca 2 to the c x minus, oh no, x because 2 to the c minus 1 is equal to 2 to c. Did I go wrong somewhere? Oh, this should be takeaway. Negative. x equals a brackets negative a brackets 2 to no, definitely went wrong somewhere. Okay. Oh no, I'm fine. Plus 2 to power c a brackets 1 to plus 2 to power c over. So this turns this plus negative 1. Okay. I don't know. How else would I do this? Equation is only possible. Is of a is for some values of minus 2 to the power 0.1 was Is it possible to teach it? X is made because yeah, okay, so log of log base x is only real negative bases can exist only real when x is greater than 0. So we replace this, we sub this in, so log 2 of a 1 plus 2 to the power c over 1 minus 2 to the power c minus a plus log a because 1 plus 2 to the power c 2 to the power c plus a, was it? A, oh no, is equal to c. So which will create log a brackets a squared over 1 minus 2 to c or square. Oh no, about there. Oh no, wait. No, we're not doing this now. We've already solved for c. No. So what would this has to be greater than 0 and this has to be greater than 0. So a brackets 1 plus 2 to the c over 1 minus 2 to the c minus a is greater than 0. Oops. It's greater than 0, and now we can just ignore this part. So a plus 2 to the power c a minus a plus 2 to the power c a is good. 2 brackets 2 to the power c a is greater than 0. Right, so c can be any value. Yeah. Actually, no. Will there actually be any solutions to this? H is 2 to power c is greater than 0. This, okay, this is equation 1. The other equation is, let's see. Um, 2 to power c, a minus 2 to power c. Oh, actually, no, this is definitely possible. Power c is greater than 0. Okay, so it cancels 2a is, is it? Minus 2 to power c plus 1. That's 2 greater than 0. So a is always good. A plus c plus 1 is... Oh, I'm way slower in this than calculus. Right. Alright, actually this is the last question. So if I get this, I will be finished. Let me just go back. For this, did I actually get everything? Can we just... I might just ignore that this happened and... G over h is k negative a, k negative a, k back negative a take away b is g from here, so we sub that in and g, 1 over h is equal to k. I can't, since f over h is equal to k squared ab, then k squared because we can't assume that f is equal to 1, I don't think. Can you get if in terms of I don't think this is relevant. I think this is the, I'm not sure, but I'm guessing this is the only relevant thing. Okay, let me just redo this. Fuck. So the log b is only real when x minus a is when x minus a is greater. X minus a is greater than 0. So a brackets 1 plus 2. Actually, no, I don't think we can ignore this. This actually does consider like a bit. This is actually a big part, I think, because a minus a plus 2 to power c a plus 2 to power c a minus 2 to power c a is greater than 0. This cancels out, so 2 to power c. A over C. And then so it's either 2 to the power C plus 1 times 2A is equal to or greater. And they have to be the same sign. So not necessarily. So 1 minus 2 to... 1 minus 2 to... So 1 minus 2 to the power C. 1 minus 2 to the power C is always negative. So therefore A is always positive for this to be real. But will this satisfy the other equation though? Since this has to... then the other lemma, what was that? Is... then is there any, what? How there's no... Can I just say there's no solution to this? Huh? Because... So 2 to the power C is always greater than 1. Therefore, A is always... Therefore, A must be less than for equation to be real. But but with... I think I should say we've created this stipulation A is good less than 0 while greater than 0 all times for no value of this is real. That this I cannot because literally the A equal to 1 and C equal to 2, like this plot, that means 1 plus 2 to the power 2 over minus 2, 1 minus 2 to the power 2, which is less than 0. Let's... Surely there's no solutions. Because if A is negative, because A brackets 1 plus 2. Because we have to be really careful when we're cancelling things out, since let's just use this for example. If we just cancel these out, 1 plus 2c is equal to 1 minus 2c, then choose that c is equal to 2 times 2 to the power c is equal to 0, 2 to the power c equals 0, c is equal to 1. No, natural log of 0, no, log of 0 is not possible. So this keeps on making actually 2 to the power c is greater than 0, and which is real for all value. Yeah, I think I can just, like, I'm gonna just pause it. I'm pretty sure this is just the answer. There's like no real solutions. There's no real combinations. It's better. Because yeah, I'm just gonna say honestly that this algebra is like really difficult, to be honest. This is definitely way harder than last year's algebra. It was very evil. Yeah, I mean this wasn't too hard. It was just weird. Then this was relatively hard, I guess. It was just no, it was kind of confusing. Then this, my teacher never taught me this in level 2, so I don't know how you were supposed to solve it without this. Then this one is like, what makes this think that this real? They specifically tell you only possible. This is implying that some values of A and some values of C is possible, but from what my inspection, it's not possible. So that's this is what's tripping me up right now. Like, all values should not be possible. I know. Okay, yeah, I know that. Thank you for watching the video, and goodbye.